Now let's see the part 3 of equilibrium. Part 3 of equilibrium. So now see the next question, that is 14. The equilibrium constant for the reactions are given like N2 plus 3 moles of hydrogen produce 2NH3. Equilibrium constant is K1. Similarly, when N2 plus O2, it produces 2NO. Equilibrium constant is K2. And when react hydrogen plus 1/2 moles of oxygen, it produces H2O. Equilibrium constant is K3. Right. So these are the equilibrium constant. You have to find the equilibrium constant for the reaction like 2NH3 plus 5/2O2 produce 2NO plus 3H2O. Right. So you have to find the equilibrium constant of this reaction by using these three equations 1, 2 and 3. So you have to just relate it. So you can see NH3 is here on the reactant side, right? But on the first reaction, it is on the product side, right? So you have to just reverse this reaction, right? So see how we'll do. So reverse this first reaction. So it will become 2NH3 dissociate to produce N2 plus 3 moles of hydrogen. So equilibrium constant will be 1/K1 then after reversing, right? And now observe this N2, right? Where it is? Now see this part 2NO. It is on the right hand side. So no need to reverse second part. So just copy it. So it will be N2 plus O2 produce 2NO. Equilibrium constant is K2, right? Now see the 3 moles of water is there. So in the third equation you have to just multiply with 3. Then equilibrium constant will be Q. Then multiply third equation by 3. So it will become 3 moles of hydrogen plus 3/2O2 produce 3 moles of water. So equilibrium constant will be K3 raised to cube, right? Now add these three equations, right? So what will happen? This nitrogen will get cancelled with this one and 3 moles of hydrogen will get cancelled with this one, right? So 1 mole of O2 plus 3 moles of 3/2O2, it will produce 2NH3 plus 5/2O2 produce 2NO plus 3 moles of water, right? So this equilibrium constant will be multiplied, right? So this will be in the numerator, second equation and third, and this will be in the denominator. So answer will be like this: K2, K3 raised to 3 divided by K1. So this is your answer. Please write the explanation also. Now see the question number 15. For the reaction CH4 plus 2O2 produce CO2 plus 2 moles of water. Delta H of this reaction is given. That is minus 170.8 kilojoule per mole. Which of the following statement is not correct about it? Right. So let's see the explanation. So product CO2 and H2 have different stoichiometric coefficient. So you can observe after reacting methane, this is your methane compound. It is reacting with O2, means oxygen. When any compound react with oxygen, it is called combustion reaction. It is called combustion reaction, right? It produces 1 moles of CO2 and 2 moles of water, right? So you can see the different phases. I will write the phases also. So methane is in the gas form. G means gas. This is also in gas form. This is also in gas form, and H2O is in the liquid state, right? So they are different physical state, different coefficient at equilibrium. So I will write the equilibrium constant for this reaction, right? When we are writing equilibrium constant, we don't consider liquid and solid state. Equilibrium constant, do not consider liquid and solid state. Liquid and solid state. So this water will be not coming in the equilibrium constant. So Kc will be equal to concentration of product. So in product CO2 is there, right? And coefficient is 1, so raised to 1 divided by CH4 methane. Concentration raised to 1. Next is O2 raised to 2. Right? And yesterday I have told that Kp is equal to Kc. RT raised to delta N. So change in mole is here. We consider only gas part, right? So what will be the change in moles? So mole of hydrogen, oxygen, CO2 is 1 minus 1 plus 2. So it will be how much? 1 minus 1 minus 2. So delta change in mole is minus 2, delta N. Right. Now put the value for finding Kp. Right. This is your Kc. This part. This value is your Kc, equilibrium constant at concentration C. C for concentration. Understood? And P for pressure. Right. So put the value of Kc from first equation. So it will be concentration of CO2 divided by concentration of CH4 raised to 1. Concentration of O2 raised to 2. Right. Into RT. Delta N is minus 2. So this will be the equation for Kp. Right. Now see. This is given Kp. So second option is incorrect for the 16 one. For the 15. Right. Now next part. This is B, right. So B part we have derived. And A is not equal concentration. So hydrogen liquid, this liquid is not considered now. So first option is also correct. Now we will discuss about now C options. So adding of CH4 and O2, the reactant will increase the concentration of reactant, and according to Lee-Chatelier principle, equilibrium shift to the right. Right. So when we are taking more moles of methane, we are increasing the concentration of methane and oxygen, then concentration of CO2 and H2O is increased. Right? It shifts to the right, towards right hand side. Why? According to Lee-Chatelier principle. According to Lee-Chatelier principles. The equilibrium shift to the right hand side. Equilibrium shift to right hand side. Shift right hand side. Right. So this will be the explanation for C option. As change in enthalpy of the reaction is negative, the reaction is exothermic. Right. So delta H value is given here. It is negative. It means the reaction is exothermic. So please remember this point. Whenever delta H is negative, that time reaction will be exothermic. So D option is also correct. So please write the explanation now. See the question number 16. In the two gaseous reactions are given at temperature 250 degrees Celsius. So reactions of first is NO plus half mole of O2 produce NO2. Equilibrium constant is K1. And for the second equation, 2NO produce 2NO plus O2. Equilibrium constant is K2. So find the relation between K1 and K2. Is there anything relation? Yes. So if you multiply second equation by 2 and reversing, First reverse the first relation, first equation, right? So it will be, after reversing, NO2 produce NO plus half O2. So equilibrium constant will be 1 upon K1. Now multiply this one. So it will be, multiply this by 2. So it will be 2 NO2 produce 2 NO plus 2 by 2 O2, and square this one. After multiplying by 2, equilibrium constant is squared, right? Now see the relation between this first equation, this second and this first, right? So what is the relation between these two? Now they are equal. K2 is equal to 1 upon K1 raised to whole square. So this will be the answer for that. So please write that one. Now see the question number 17. The reaction quotient. So reaction quotient is given, that is Q. Right. For the reaction, like nitrogen plus 3 moles of hydrogen react and produce 2NH3. So Q is given by concentration of ammonia raised to 2. Coefficient we write, right? Divided by N2, concentration 1. H2 raised to 3. So this is the reaction quotients. So the reaction will proceed towards right hand side. It is talking about right hand side. So we have to produce more numbers of moles, right? For this concentration, we have to increase. So what is the relation between QC and Q? For any reaction to proceed in forward direction, the reaction quotient should be less than the equilibrium constant, right? So to move forward, right? So forward reaction. So Q, reaction quotient, should be less than equilibrium constant. So this is the main point, right? So this value should be less. For this, to make this less, this concentration should be less and more number of reactants should be there, right? So we have to add more number of this reactant part, like nitrogen and hydrogen. So write them this main point, right? And for to make the backward, what should be the relation? This should be reverse. So Q will be greater than Kc. This is the backward reaction condition. And for equilibrium, Q will be equal to Kc. This condition is at equilibrium. So please add these 2 points more. That can be asked in another question also. Now look at the question number 18. For the reaction like BaO2 produce BaO plus O2, right? Barium dioxide produce barium oxide plus O2, and delta H for this reaction is given, that is positive. So it will be endothermic reaction, right? So in equilibrium condition, it is also given another point. In equilibrium condition, pressure of O2 depends on, pressure of O2 depends on, it is asking, right? So see the explanation for this one. Barium dioxide dissociates. So write the equilibrium constant for this reaction. So it will be Kc is equal to concentration of barium oxide, concentration of O2 divided by concentration of BaO2. Right. So BaO2 and BO are in the solid state. So it is given. States of the reaction is also given. So write that one also. So this is in the solid state. I will write with different color. And this is also solid, right? And this is your gas form. So BaO2 and BaO are in solid state. Thus, their concentration is constant, so doesn't change. Hence, equilibrium constant is independent of these two concentration term, right? So this is constant and this is also constant. So this Kc will be reduced to only O2 concentration, right? So thus increase the mass of BaO2 and BO doesn't have the effect on equilibrium constant, right? So if you are changing the mass of this BaO2 and BaO, right, their value doesn't affect the equilibrium constant, right? So write the statement here. BaO2 and BaO are in solid state. So after changing the concentration of BaO2 and BaO doesn't affect the equilibrium concentration. Equilibrium concentration or equilibrium constant. So and delta H is given positive, right? So that will be the endothermic reaction. The reaction is endothermic. So delta H value is positive. That is endothermic reaction. Then the increase in temperature will favor the forward direction of equilibrium. So as temperature increases, reaction is in the forward, right? Hence more O2 is formed. So this will be the third point. So more O2 is formed now. Right? And higher will be the pressure of O2. So increasing temperature, pressure also increases. Pressure also increases. So write the explanation. Now see the question number 19. When magnesium carbonates dissociate, it forms magnesium oxide solid plus O2 gas. So this is in the solid state, this is also in the solid state. Which one is the correct expression, right? So for equilibrium constant, solid is not considered. So it is directly concentration of O2 will be there, right? So you can see. And for, we have to find Kp. So Kp is nothing but it is Kc into RT raised to delta N. So remember this formula, relation between Kp and Kc. So now we know this is constant, 1 mole, 1 mole. So it will not consider in the moles. So change in moles will be 1 only. So Kp is equal to Kc value put here. So it will be O2 raised to RT raised to 1. So this will be the answer. So first is the correct answer. Right. And if you want to write in the partial pressure form, then it will be the partial pressure of O2. Right. So Kp is nothing but, it can be written as like this, partial pressure of O2. Right. So Kp will be equal to partial pressure of O2. This will be the formula. Now see the question number 20. For a reversible reaction, if the concentration of reactant are doubled, the equilibrium constant will be. So it is talking about reversible reaction. Reversible reaction. So for reversible reaction, if the concentration of reactant are doubled, suppose A is producing B. So when we double the concentration of A, so what will be the effect on concentration of B? We have to talk about it. So and for equilibrium constant also, right? So see, equilibrium constant of reaction is independent of the concentration of a species involved in the reaction, but depends on the temperature. If the concentration of any species increases, then the concentration of other species also increases according to keep the equilibrium constant same. So let's see. So it will be the same. Why? Because concentration will be written like this. So if it is double, so it will also become double, right? Because they are directly proportional. So for first equilibrium constant will be concentration of B divided by concentration of A. So while being doubling that one, then it will become concentration of B raised to 2 divided by concentration of A raised to 2. So both are becoming double, right? So by changing concentration, equilibrium constant doesn't change. So Kc does not change, right? This will be the value, right? If we increase the temperature, so equilibrium constant will be moved forward. So here it is not talking about temperature and pressure also. So it is talking about just the concentration. So increasing the concentration, equilibrium constant doesn't changes. So it will remain same. So answer will be remains same because it is independent of concentration. Independent of concentration. So write this one.